Good evening, everyone. Okay, for today's problem. So the problem states if an object slides on a surface, the frictional coefficient is calculated as mu equal to F by L. So which means you have a surface, you have an object over here of mass M. And now let us say it slides. Okay, as it is sliding, it comes to this point. As it is sliding, the frictional coefficient here mu is equal to the net force acting divided by M. This is what you can say, or the net force F, not even F, the net force, you can say that this F is nothing but your weight. Okay, so you can say that this is weight divided by F. Okay, so this is what you can say. And you can easily find out W is equal to, frictional force, I'm sorry, not this way. Frictional force is equal to, my pen is not writing, okay, mu times N. Okay, and we know that N is equal to mg, so mu times mg, and as a result of it, now you can say this frictional force Ff divided by mg is equal to mu. This is a normal way which you calculate. Now the question is not this. The question is, you have, let us say I have a string and I have an object tied at the end of the string, okay, connected over here. Now what I do is about this axis, if I am rotating it, if I'm making it to go around the circle, okay, something like this. So it moves with an angular velocity omega. Now the question is, how do I calculate the friction? Should I still calculate the friction based on F equal to mu times N, or is there some other way? Because you see, here also there is an N here. There's an N here. Okay, now how do we do it? This is a question. So towards it, so many of them, what they do is they find out what is the mass, they find out what is Ng, and then they substitute it over here and get the value of mu and finally get the value of the frictional force. Okay, but sometimes, especially when there's a rolling like this might be incorrect. Now, how do we calculate it? We calculate it like this. See, there's a string connected here. This string is now pulling the object towards the center. Let us say string is pulling the object like this over here. And whenever an object is moving in a circular path, centripetal force comes into play, which means this tension is nothing but m omega square r. This is your centripetal force. Now, as a result of this object should now come nearby to it. In other words, it should fall to the center. But it's not falling to the center. Why? See, if it had, it's not certainly not centrifugal force. Okay. So centripetal and centrifugal are opposite to each other, but doesn't mean that you are describing an object here. Centripetal should be acting, okay, on this object in this direction. So we should not consider centrifugal force. The force that acts opposite to it is nothing but your frictional force. Okay. Now frictional force opposes this m omega square r. As a result of this, you can now write frictional force is equal to m omega square r. Our frictional force, as we know, you can easily calculate using this. And now you can substitute mu times m is equal to m omega square r, or mu times mg is equal to m omega square r, or mu should be equal to omega square r divided by g. Okay, you can calculate the value of mu using this and not just by making use of n divided by frictional force is equal to mu or any other method. Okay, I hope this is clear. So we will look at the next lecture more on these kinds of problems. So let me stop here. If you like this video, do like, share, subscribe to my channel for further updates. Thank you, students.